I'd like to ask you some questions.
Of course, go ahead and ask your questions whenever you're ready.
What is the shape of the Earth?
The Earth is mostly spherical in shape, but it's slightly flattened at the poles and slightly wider at the equator. This shape is called an oblate spheroid.
Was our understanding of the shape of the Earth a political or religious decision, or is it based on measurements?
Our understanding of the Earth's shape is based on scientific measurements and observations, not political or religious decisions. Ancient Greek philosophers like Pythagoras and later astronomers observed the Earth's round shadow on the moon during lunar eclipses, and they reasoned that the Earth must be round. Modern measurements, satellite imagery, and space exploration have all confirmed that the Earth is an oblate spheroid.
Is there any scientific evidence that the Earth is flat?
No, there is no scientific evidence supporting the idea that the Earth is flat. The overwhelming scientific consensus, based on centuries of observations and measurements, is that the Earth is an oblate spheroid. Evidence supporting this includes satellite images, space travel, circumnavigation, and the way gravity works. The idea of a flat Earth is a misconception that has been debunked by scientific research.
Why does the horizon appear flat from a beach if the Earth is a sphere?
The horizon appears flat from a beach or any other vantage point because the Earth is very large compared to the size of what we can see. When you're standing on the ground, the curvature of the Earth is too subtle to notice over short distances. The horizon looks flat because it's so far away that the curvature isn't noticeable to the naked eye. However, if you were to travel a great distance or view the Earth from a high altitude, the curvature would become more apparent. Also, with tools like telescopes or from space, the spherical shape of the Earth is clearly visible.
Why do some people still think that the Earth is flat?
Some people continue to believe the Earth is flat due to a variety of reasons, including skepticism of scientific authorities, misinformation, and exposure to conspiracy theories. In some cases, it can also be a form of identity or community for certain groups. It's important to approach such beliefs with understanding and provide clear, evidence-based information to help address misconceptions.
Is thinking that the Earth is flat a common belief?
Thinking that the Earth is flat is not a common belief among the general population. The scientific consensus, based on extensive research and evidence, supports that the Earth is an oblate spheroid. While the flat Earth belief exists among a small minority, it is not representative of mainstream understanding. Most people accept the scientific evidence that the Earth is round.
Is the belief in a flat Earth growing or staying the same or decreasing?
The belief in a flat Earth appears to be relatively stable or even decreasing over time. As access to information and education improves, and scientific understanding spreads, most people tend to accept the scientific consensus that the Earth is round. While there may be pockets of people who hold on to flat Earth beliefs, they represent a small minority. Overall, scientific literacy and understanding continue to grow, leading to a decline in such misconceptions.
Is believing in a flat Earth suggestive of a learning disability?
Believing in a flat Earth is not indicative of a learning disability. People may have various reasons for holding different beliefs, including exposure to misinformation, skepticism, or a lack of access to certain types of information. It's important to approach these situations with understanding and empathy, providing clear and respectful information to help address misconceptions.
What are the reasons that people who believe in the flat Earth reject scientific measurements showing the Earth to be a sphere?
People who believe in a flat Earth typically reject scientific measurements showing the Earth is spherical for several key reasons. 1. Conspiracy theories. A significant number of flat Earth believers think that governments, space agencies like NASA, and scientists are part of a vast conspiracy to conceal the true nature of the Earth. They often believe that the evidence of a round Earth is fabricated as part of a control mechanism. 2. Personal experience and perception. Many flat earthers rely on their own observations, such as the fact that the horizon often appears flat from their point of view. They may not observe any visible curvature, even from great heights, and interpret this as evidence that the Earth is flat. 3. Misunderstanding or rejection of scientific evidence. Some flat Earth proponents misunderstand basic scientific principles like gravity, the curvature of the Earth or the way light bends in the atmosphere. They may dismiss photos of Earth from space as altered or fake and claim that scientific measurements are flawed or deceptive. 4. Religious or cultural beliefs. Some flat Earth believers refer to religious texts or ancient cosmologies that describe the Earth as flat. These beliefs shape their rejection of modern science in favor of traditional or religious views of the world. 5. Echo chambers and community influence. Online communities and social groups that believe in a flat Earth often reinforce these ideas. The support of like-minded people creates an environment where contradictory evidence is dismissed and groupthink takes over. 6. Cognitive dissonance. When confronted with evidence contradicting their belief, flat Earth believers may experience cognitive dissonance, a psychological discomfort from holding conflicting ideas. To resolve this, they may double down on their beliefs and reject the scientific evidence even more strongly. 7. Alternative explanations. Some flat Earth believers propose alternative models to explain phenomena like gravity, the behavior of the stars, or the Earth's horizon, which they argue better fit their observations than the spherical Earth model. These reasons, ranging from distrust of authority to misunderstandings of science, all contribute to the rejection of scientific measurements, showing that the Earth is a sphere.
Is the belief in a flat Earth a conspiracy theory?
Yes, the belief in a flat Earth is often tied to conspiracy theories. Many flat Earth proponents believe that governments, space agencies like NASA, and other institutions are deliberately hiding the truth about the shape of the Earth. They argue that all the scientific evidence supporting a spherical Earth, such as satellite images, physics experiments, and centuries of observations, is fabricated or manipulated as part of a global conspiracy. In this view, the belief in a round Earth is not just a misunderstanding of science, but part of a coordinated effort to control the population and suppress the truth about the Earth's flatness. This aspect of the belief aligns it closely with other conspiracy theories, where adherents view most mainstream sources of information as unreliable or intentionally deceptive.
What is the difference between a true conspiracy and a conspiracy theory?
The key difference between a true conspiracy and a conspiracy theory lies in the nature of the evidence and the reality of the situation. A true conspiracy refers to a real, secretive, and unlawful plan carried out by a group of people with the intent to achieve a specific goal, often for personal, political, or financial gain. In a true conspiracy, there is concrete evidence or proof that the conspiracy actually took place. Examples of true conspiracies include events like the Watergate scandal or the covert actions of organizations like the CIA in history. On the other hand, a conspiracy theory is a belief or hypothesis that a secret, often nefarious plan is being carried out by powerful groups or individuals, but without verifiable evidence to support it. Conspiracy theories often rely on speculation, mistrust of official sources, and selective interpretation of facts. They typically involve complex webs of supposed hidden agendas that aren't grounded in solid proof. So, while a true conspiracy is a documented event with real verifiable outcomes, a conspiracy theory is an unproven idea or belief that is often based on speculation and suspicion rather than factual evidence.
Do people that believe in a flat Earth lack deductive reasoning skills?
It's not necessarily that people who believe in a flat Earth lack deductive reasoning skills entirely, but rather that they may interpret evidence in ways that reinforce their existing beliefs, rather than critically analyzing it from multiple perspectives. Cognitive biases, like confirmation bias, play a big role. People tend to look for information that supports their views and dismiss evidence that contradicts them. Additionally, some flat Earth believers may misunderstand or misinterpret scientific concepts, which can make it harder for them to apply logical reasoning to the overwhelming evidence that supports a spherical Earth. It's also important to note that belief in a flat Earth can be influenced by factors like distrust of authority, social influences, or personal experiences, which can further cloud logical thinking. That being said, reasoning ability can vary widely among individuals. So it's not necessarily about a lack of skill in general, but rather how those skills are applied or influenced by other factors.
Is believing in the flat Earth consistent with critical thinking skills?
Believing in the flat Earth is generally not consistent with critical thinking skills, particularly when it comes to evaluating evidence. Critical thinking involves objectively analyzing information, questioning assumptions and considering alternative explanations based on reliable, evidence-based reasoning. Flat Earth belief tends to involve rejecting overwhelming scientific evidence, like photos from space, gravitational physics, and centuries of astronomical observations, in favor of personal perceptions or conspiracy theories. While someone who believes in the flat Earth may think they are using critical thinking, they often rely on flawed reasoning or selective evidence. For instance, they may dismiss established facts or argue against well-documented scientific principles without fully understanding them. This kind of thinking typically falls into cognitive biases, like confirmation bias, where a person selectively accepts information that fits their pre-existing beliefs and ignores information that contradicts them. So, while individuals may believe they are engaging in critical thinking, their reasoning often lacks the open-mindedness and willingness to revise beliefs in the face of strong, credible evidence, which are core principles of true critical thinking.
Is there a conspiracy to hide the true shape of the Earth? And if so, to what benefit?
There is no credible evidence to support the idea that there is a conspiracy to hide the true shape of the Earth. The belief that the Earth is flat and that a conspiracy is involved to conceal its true shape is part of a conspiracy theory, which generally lacks solid, verifiable evidence. However, people who subscribe to this belief often claim that the conspiracy is orchestrated by governments, space agencies like NASA, or other powerful entities. According to these beliefs, the motivation for such a conspiracy might be control, manipulation, or maintaining a certain narrative to suppress the truth about the Earth. Some proponents argue that if people realized the Earth was flat, it would disrupt the established order of science, history, and society, though there is no logical basis for these claims. In terms of tangible benefits, flat Earth proponents might argue that the conspiracy helps maintain control over education, keeps the population ignorant, or protects the financial interests of space exploration organizations. But again, these ideas are speculative and not grounded in any proven facts. The scientific community has overwhelmingly demonstrated through centuries of evidence, from ancient astronomy to modern satellite imagery, that the Earth is a sphere. So the idea of a vast conspiracy to hide this truth doesn't have any real-world support or practical benefit.
Does presenting evidence of the globe Earth cause the believer in a flat Earth to double down on their belief?
Yes. Presenting evidence of a spherical Earth can often cause a flat Earth believer to double down on their beliefs, and this is a phenomenon known as cognitive dissonance. When confronted with information that contradicts their worldview, people tend to experience discomfort because it challenges their deeply held beliefs. To resolve this discomfort, rather than changing their beliefs, they may double down on them by finding ways to dismiss or discredit the evidence. There are several psychological and social reasons why this happens. 1. Cognitive dissonance. When flat Earth believers are presented with overwhelming evidence of a spherical Earth, the internal conflict they feel between their beliefs and the new information may cause them to reject the evidence to preserve their worldview. 2. Confirmation bias. Many people who hold strong beliefs, like the flat Earth theory, tend to seek out information that supports their existing views while disregarding information that contradicts them. This bias makes it easier for them to dismiss scientific evidence as fake or part of the conspiracy. 3. Social and identity factors. For some, belief in the flat Earth theory can become a part of their social identity, especially within communities or online groups where such beliefs are reinforced. Questioning or abandoning these beliefs could feel like a loss of identity or social belonging, leading them to resist changing their views. 4. Mistrust of authority. Many flat Earth believers deeply mistrust institutions like NASA, scientists, and governments. As a result, when evidence comes from these sources, they are more likely to dismiss it as part of the perceived conspiracy rather than reconsider their beliefs. In short, the presentation of evidence is often seen as a threat to their worldview, leading them to become more entrenched in their beliefs rather than reconsidering them. This is a common pattern in various types of belief systems, not just flat Earth theory.
Is a scientific theory different than what we would call a theory in usual use?
Yes, a scientific theory is quite different from the way the word theory is commonly used in everyday language. In casual conversation, theory often refers to a guess, hypothesis, or something unproven, like a mere idea or speculation. However, in scientific terms, a theory is a well-substantiated explanation of some aspect of the natural world that is based on a body of evidence and has stood up to repeated testing and scrutiny. It is not just a guess, but a comprehensive framework that explains and predicts phenomena based on extensive data and observations. For example, everyday use. I have a theory about why my plants aren't growing well. Maybe they need more sunlight. Scientific use. The theory of evolution by natural selection explains how species evolve over time based on genetic variation and natural processes. Scientific theories are supported by a large body of evidence and are tested through experiments and observations. They are not speculations, but rather conclusions that explain how things work, and they can be modified or refined as new evidence comes to light. Examples of scientific theories include the theory of gravity, the germ theory of disease, and the theory of relativity. So, while both types of theories involve ideas, a scientific theory has undergone rigorous testing and is widely accepted by the scientific community as the best explanation available based on current evidence.
Is gravity just a hypothetical concept?
No, gravity is not just a hypothetical concept. It's a well-established physical force that has been extensively tested and observed in many different contexts. While we may not fully understand all of its intricacies, like the true nature of gravity at the quantum level, its effects are measurable and predictable. Gravity is the force that attracts objects with mass toward one another. This is why, for example, objects fall toward the Earth, why the Earth orbits the Sun, and why the Moon orbits the Earth. Isaac Newton's law of universal gravitation and Albert Einstein's theory of general relativity are both key explanations of gravity, each providing a different level of detail and accuracy. Newton's law explains gravity well in many everyday situations, but Einstein's theory provides a more accurate description, especially in extreme conditions like near very massive objects, e.g., black holes, or at very high speeds. In modern science, gravity is a fundamental force, and its effects are observable all around us, from the falling of an apple to the way the planets move. So it's far more than a hypothesis. It's a well-supported scientific phenomenon.
Are both luminiferous ether and spacetime scientific theories?
Luminiferous ether and spacetime are both concepts in the history of physics, but they represent different ideas and have very different status in terms of scientific theories. Luminiferous ether. The luminiferous ether was once a proposed medium thought to fill all of space, through which light waves were believed to travel, much like sound travels through air. This idea was widely accepted in the 19th century, based on the notion that waves, like light, need a medium to propagate, similar to how sound waves need air or water to travel. However, the theory of the luminiferous ether was discarded in the early 20th century after Albert Einstein's special theory of relativity in 1905. Einstein showed that light can travel through the vacuum of space without needing a medium, and experiments such as the Michelson-Morley experiment failed to detect any evidence of the ether. Thus, the concept of the luminiferous ether is no longer considered a valid scientific theory and is regarded as an obsolete idea in the history of physics. Spacetime. Spacetime, on the other hand, is a fundamental concept in modern physics, particularly in Einstein's theory of relativity. It combines the three dimensions of space with the one dimension of time into a four-dimensional continuum. This framework explains how space and time are interconnected and how they are affected by gravity and motion. In general relativity, space-time is curved by the presence of mass and energy, and this curvature is what we perceive as gravity. Unlike the luminiferous ether, space-time is a scientifically validated concept that has been confirmed through numerous experiments and observations, including the bending of light around massive objects, gravitational lensing, and the detection of gravitational waves. Summary. Luminiferous ether was a once popular but now discarded scientific theory that has been replaced by modern understandings of light and the vacuum of space. Spacetime is a well-established, scientifically supported concept in physics, central to our understanding of the universe and the theory of relativity. So, while spacetime is a key part of modern scientific theory, luminiferous ether is no longer a valid scientific theory, having been disproven by experimental evidence and replaced by more accurate theories.
In the geocentric model of the solar system, what is the shape of the Earth?
In the geocentric model of the solar system, which was widely accepted in ancient times, especially by the Greeks and the Romans, the Earth is considered to be at the center of the universe, and all celestial bodies, including the sun, moon, and planets, revolve around it. In terms of the shape of the Earth within the geocentric model, it was typically assumed to be spherical. Ancient astronomers, such as Aristotle, argued for a spherical Earth based on observations like the shape of the Earth's shadow during a lunar eclipse and the way ships disappear hull first over the horizon. The spherical Earth was a widely accepted idea even before the heliocentric model, which places the sun at the center, was proposed. So, in the geocentric model, the Earth is still spherical, but the main idea is that it is the immovable center of the universe, with the sun, planets, and stars all orbiting it. The shape of the Earth itself was not significantly questioned in this model. What was debated was the structure of the cosmos and the motion of celestial bodies around the Earth.
What is the physical evidence for the rotation of the Earth versus the rotation of the stars above us?
The evidence for the rotation of the Earth versus the rotation of the stars above us comes from a variety of physical observations and experiments. Here are some of the key pieces of evidence supporting the Earth's rotation. The Foucault pendulum, first demonstrated by French physicist Léon Foucault in 1851, provides direct evidence that the Earth is rotating. The pendulum swings in a constant direction, but the plane of its swing gradually rotates over time. This effect occurs because the Earth is rotating beneath the pendulum. The rate of rotation depends on the latitude. The closer to the poles, the faster the apparent rotation of the pendulum. Coriolis effect. The Coriolis effect refers to the deflection of moving objects, like wind or ocean currents, caused by the rotation of the Earth. In the northern hemisphere, moving objects are deflected to the right, while in the southern hemisphere, they are deflected to the left. This effect is observable in weather patterns, such as the rotation of large storms, e.g. hurricanes, and the flow of ocean currents. Day-night cycle. The apparent motion of the sun across the sky, from east to west, provides indirect evidence of Earth's rotation. If the Earth were stationary and the stars were rotating around us, we wouldn't observe the daily rising and setting of the sun. The Earth's rotation on its axis causes the sun to appear to move across the sky, with the cycle repeating every 24 hours. 4. The motion of the stars. The stars themselves do indeed appear to rotate around the Earth, but this is actually due to the Earth's rotation, not the stars moving. Over the course of a night, stars seem to move in circular paths around the celestial poles, which are near the North and South poles. This motion is a result of the Earth's rotation. The fact that the stars appear to rotate around a fixed point, the celestial poles, is evidence that it's the Earth that's turning. Observations from satellites in space. Modern satellite observations and images taken from space clearly show the Earth rotating. These observations provide visual and photographic evidence of the Earth's movement. 6. Centrifugal force. The equatorial bulge of the Earth, where the Earth is slightly wider at the equator, is caused by the centrifugal force from the Earth's rotation. This would not occur if the Earth were stationary. The Earth's equatorial radius is larger than its polar radius, which is consistent with a rotating sphere. The stars' apparent motion. While the stars appear to move across the sky, their motion is a result of the Earth's rotation. The stars themselves are not physically rotating around the Earth. Instead, as the Earth rotates on its axis, it gives the illusion that the stars are moving. This is why, depending on your location on Earth, different stars appear in the sky at different times of the year, and some stars are visible only during certain seasons. In summary, the combination of physical experiments like the Foucault pendulum, the Coriolis effect, the observable motion of the stars, and modern satellite imagery all point to the Earth rotating on its axis. The stars' movement is an effect of the Earth's rotation rather than the stars themselves rotating around the Earth.
Is talking about the flat Earth a scientific discussion? And is it a viable alternative to globe Earth?
Talking about the flat Earth in a scientific context is not typically a productive scientific discussion, as it goes against well-established scientific principles. The idea of a flat Earth has been thoroughly debunked through centuries of observation, experimentation, and evidence across multiple fields of science, including astronomy, physics, and geology. Modern science, based on a vast body of evidence, overwhelmingly supports the concept of a spherical Earth. This is not just an idea or hypothesis, but a well-supported, tested scientific fact. Why flat Earth is not a scientific discussion. 1. Overwhelming evidence. The Earth's spherical shape is supported by a wealth of observable and measurable evidence, such as satellite images, gravitational measurements, and the way ships disappear over the horizon. The consistency of the spherical Earth model in explaining phenomena like time zones, the Coriolis effect, and the motion of celestial bodies makes the flat Earth model scientifically irrelevant. 2. Scientific method. A scientific theory is based on evidence, experimentation, and the ability to make predictions. The flat Earth model lacks these aspects. There's no testable hypothesis that can be used to prove or disprove the flat Earth claim in a scientific way, especially when compared to the abundance of evidence supporting a spherical Earth. 3. Conspiracy and misinterpretation. Many people who advocate for the flat Earth believe that there is a vast conspiracy to hide the true nature of the Earth. However, this belief does not rely on scientific evidence and is instead based on skepticism of established institutions and often flawed or misunderstood interpretations of science. Is the flat Earth model a viable alternative? No. The flat Earth model is not a viable alternative to the spherical Earth model from a scientific standpoint. Here's why. Gravitational forces. The flat Earth model cannot adequately explain the force of gravity, which is why we experience weight and why objects fall towards the center of the Earth. Gravity, as understood in the context of a spherical Earth, works by pulling objects towards the center of mass, which naturally shapes a planet into a sphere. Astronomical observations, the movement of the stars, planets, and the sun, along with their observed positions in the sky, aligns with the spherical Earth model. The way lunar eclipses occur, with the Earth's round shadow cast on the moon, the phases of the moon, and the curvature of the Earth seen from different locations around the world all point to a spherical planet. Photos from space, thousands of images taken by astronauts and satellites, clearly show the Earth as a sphere. These images come from different countries, space agencies, and private companies, providing a vast amount of consistent evidence that the Earth is round. International collaboration. The collaboration between scientists across the world, from different political systems and backgrounds, consistently supports the spherical Earth model. This would be nearly impossible if there were a global conspiracy to hide the truth. Conclusion. The discussion about the flat Earth model is not considered a scientific one because it disregards vast amounts of well-documented empirical evidence that supports the spherical Earth. The flat Earth hypothesis fails to provide any viable, testable, or credible alternative to the spherical Earth, which is consistent with centuries of scientific observation and experimentation. The persistence of the flat Earth belief often stems more from misconceptions, skepticism of authorities, or social factors rather than scientific merit. Therefore, it is not a scientifically viable alternative to the globe Earth model.
Thank you very much.